All right. Hello, everybody. I'm going to work through that exercise that was in your workbook from last time. And this was all about the equation CO2 plus H2 is in equilibrium with CO, or carbon monoxide, and H2O. Now, we're given a couple of pieces of information for this problem. First and foremost, we're given an equilibrium constant. K sub C is equal to 0.20. This has no units because this is a ratio of concentration, so all the units would cancel out. All right, now what we are also given is we are given some information in an ICE table, ICE. And in that ICE table, we are told, well, it's structured a little bit differently than an ICE table because it asks about the initial number of moles, which is 1.00, the initial number of moles of H2, which is 2.00, and then it tells us the initial number of moles of our products, CO and H2O. Both are 0. Then it goes on to talk about our change, which would be the C here, our change in moles, which is simply going to be, just going to change color here, minus X, because we don't know how much carbon dioxide is utilized. We also don't know how much H2 is utilized, but we can say minus X is just a placeholder. And as a result, since we have a molar ratio of 1 to 1 to 1 to 1, we can say that the amount of carbon monoxide that is added is plus X. The amount of H2O that is added is also plus X. Now, what we then are given is, or then are asked about, is our equilibrium. But first this says equilibrium moles, so 1 minus X, 2 minus X, and X and X. But then the next row below that, which I'm just going to label E, but I'm going to bracket it to indicate molar concentration. Well, this is where we convert from number of moles to our concentration, because that's what we want to know, because this number right here, K sub C, is a ratio of concentrations. So what we need to do is we need to figure out what is our concentration of our different species at equilibrium. Well, carbon dioxide we have 1 mole, but if we want to figure out our concentration, we have to have, well, a volume. And as it turns out, we are given that. This is all taking place in a 5.0 liter canister or container or reaction vessel. And so what we can do is we can take our number of moles, which is indicated here and here, and divide it by 5. So our equilibrium concentrations are 0.2 minus X, and 2 divided by 5 is going to be 0.4 minus X. This doesn't change any of the other variables because, well, X, it remains to be solved for. Now, what we want to do with this information is we want to set up our equilibrium expression. Our equilibrium expression, K sub C, when we use our products, we would say H2O times carbon monoxide is divided by CO2 times H2. Okay, so those are our products at the top and our reactants at the bottom. Now we have these concentrations. There's a little bit more to solve, but we can do that. And so what we're going to do is we're going to put our values in. K sub C is equal to, do we know the concentration of H2O? We do, it's X. Do we know the concentration of carbon monoxide? We do, it's also X. Do we know the concentration of CO2? We do, it's 0.2 minus X. What about H2? Well, that's 0.4 minus X. Okay, so I'm going to go ahead and write this as all equal to 0.20 because that's our K sub C. Now, what we really want to do with this information is we want to combine as many factors as possible. So I'm going to write 0.20 is equal to X times X, or X squared, divided by, and then I'm going to take what's in this parentheses and this parentheses and I'm going to combine those two. So 0.2 times 0.4 is 0.08. Okay. Then this 0.2, I'm distributing this. So I first distributed it to 0.4, and now I'm distributing it to the x. So that would be this would be minus 0.2x. Okay, what else is there? I'm going to go ahead and erase some of these things so I can keep track of my notes. Well, I would take that this x factor, I'm going to multiply that by 0.4. So that would be minus 0.4x. And this next one, x times x, is plus, those are both negative x's, so it's going to be plus x squared. So I'm going to rewrite this just so I can combine as many variables as possible. And I'm going to say x squared divided by, I'm going to start out with x squared minus, combine these two because they both have a common x variable there. So I'm going to say that's minus 0.6x plus 0.08. All that is equal to 0.20. Okay, so this function right here has everything that I need to know. Now, what's worth knowing is that there's kind of a, we can use this information and plug it into the quadratic equation. The quadratic equation is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now what I need to do is I need to deduce what are my different a, b, and c. Well, a, b, and c. Sorry, that's incorrect. I jumped ahead of myself there a little bit. Because I have all these variables, I've got this x squared up here, I've got an x squared down here, and then I've got this 0.20. What I'm going to do is I'm going to take this part of my equation and multiply it by 0.20. So I'm going to say, well, x squared times 0.20. Since I'm taking this right here and multiplying it by this, I'm going to set up the equation x squared equals, because x squared on the top will be by itself. X squared is equal to 0.20x squared. Okay, then I'll take this, negative 0.6 times 0.2. Well, negative 0.6 times 0.2 is going to be negative, or sorry, it's going to be, negative 0.12x. Last but not least, I've got 0.08 times 0.2, and that's going to be plus 0.016. Okay, so now that I have this equation right here, what I'm going to do is I'm going to leave this x squared on its own side and subtract everything on the right side of my equation to get it onto the left side of the equation. So x squared, I can subtract from that 0.20x squared. Well, this is effectively 1 minus 0.2, which gives me 0.80x squared. Subtracting negative 0.12 gives me positive 0.12x. Subtracting the 0.016 equals 0. So I set my entire equation to 0. Now that I have this equation right here, what I can do is look back at my quadratic equation. This is A, this is B, this is C. Okay, so I'll set up my equation and I'll say x is equal to negative b, which that would be negative 0.12 plus or minus the square root of b squared. So that's 0.12 squared minus 4 times a, which is 0.8, times c, which is negative 0.08. Now, I use a very simple calculator, so I'm going to be very deliberate with all of these steps. This is all over 2a, which is 2 times 0.80. All right, now that I have all that set up, what I'm going to do is I'm going to say this is equal to negative 0.12. I'll erase some of this stuff over here to give myself a little bit more space. And let's see, I can select. Look at that. My computer whiz. Okay, so that's negative 0.12. That is plus or minus the square root of, now I gotta start plugging functions in. So 0.12 times 0.12 equals 0.12 times 0.12 equals 0.0144. Okay, subtract from that 4, and this would be a, well, you could say negative 4 times 0.8 times negative 0.016. And that would give you 0.0512. But since this is a negative value and this is a negative value, effectively this is going to be plus 0.0512 divided by 2a, which is 1.6. Okay, so now as I continue working through this, I'm going to say negative 0.12 plus or minus, and now I've got it, I'm kind of at a crossroads here. Well, I want to combine these. 0.0144 plus 0.0512. When I add those up, I get 0.0656. So negative 0.12 plus or minus the square root of 0.0656. This is all divided by 1.6. Okay, so I'm basically looking at, and I'm going to work below here, so negative 0.12. I'm just going to go with plus. So I'm going to start out by adding, because I know that I have a negative value here, and chances are, if I'm subtracting from a negative value, it's going to become more negative. But before we worry about that, let's go ahead and say plus negative 0.12 plus the square root of 0.656. So I'm going to hit shift and I get this value, 0.2561 divided by 1.6. Okay, I'm going to set this equal to, so I've got negative 0.12 plus 0.2561 divided by 1.6. That gives me 0.085 equals x. So that's my x value. Now, let's go ahead and, just for the sake of the fun of it all, negative 0.12 minus 0.2561. Okay, so 0.12 negative minus 0.2561. That gives me negative 0.3761. Now, if I end up with a negative number in my numerator, that means my overall number that I'm solving for is also going to be negative. Can I have a negative concentration? I cannot. So I know that number is basically invalid. So I've got this x value right here, which is exactly what I was looking for. I'm happy with that. Now, what I want to do is I want to go ahead and confirm this. Since I've solved for x, I'm going to go ahead and go back to my equilibrium expression right up here. And I'm going to take this 0.085. This is a little bit of a what's called a confirmation bias, but I'll say 0.085 squared. Plug in that 0.085. And then I'll do 0.2 minus 0.085. That is equal to 0.115. Okay. Now, next up is 0.4 minus 0.085. That is 0.315. Okay. Now, I plugged those values in because those are my concentrations at equilibrium. Now, what I should be able to do is plug all of these values in and solve, and my number should be 0.2. So I'm going to go ahead and do that. 0.085 times 0.085 equals 7.225 times 10 to the negative third divided by 0.115 times 0.315 equals 0.036225. Okay, now I will take that 7.225 times 10 to the negative third divided by 0.036225. Plug that in, and I get a value of 0.1994785. And you know what? That rounds up to 0.2. So I'm pretty happy with that. I trust those numbers, and I'm confident with the work that I did there. So this is an involved problem and a challenging problem. So don't get discouraged or frustrated, or well, you're free to get frustrated, but don't let that stop you from working to complete it. Now, I'd say that there are a couple of things that are very important. One, keep in mind that we're concerned with the concentration. So you need to know what the volume is in which this reaction is taking place, okay? Because that helped us get this value right here, and therefore we could relate all of these to our K sub C. Now, you do have the added variable of the quadratic equation. So that does present a little bit of a challenge, but that's not to say that it's insurmountable. I would recommend doing what I did and work very deliberately. Point out what is my A value, what is my B value, make sure everything is equal to 0, and then proceed. I would say those are kind of the toughest parts about this sort of problem. At any rate, I hope this was helpful, and I hope you have a great day.